Alright, so we'll go through this one at a time. For part A, the initial direction of the flux in the loop is obviously into the page. It's in the same direction as the external magnetic field. For part B, we've got the left side of the loop over here is coming out of the page, and then the right side of the loop is going into the page. So, and it's rotated 90 degrees in 15 seconds. Now delta phi in this case then can be calculated from BA times the change in cosine theta, because it's that angle that's causing the change in flux. The external field is constant, the area of the loop is constant, but the angle is changing. And the angle is changing from 1 to 0. So this is, well, let's see, the magnetic field is 45 Tesla. The area, oh, it's 25 turns as well, so I got to put an N on this, don't I? So it's 25 times 45 Tesla. And then we have pi r squared for the area. The radius of this thing is 33 centimeters. And delta cosine theta is 1. Right, because initially cosine theta is 1, but once this loop turns so that it's sideways, cosine theta term is 0. So delta cosine theta is 1. Now the EMF is delta phi B over delta T. I guess I got a little bit ahead of myself, didn't I? For the answer to B, it says, how's the flux changing in the loop? Well, it's decreasing. Sorry about that. And then the direction, and it's decreasing because delta cosine theta is going from 1 down to 0, right? Alright, so anyway, and the direction of the induced magnetic field in the loop for part C, we're going to come back to this, don't worry. The direction of the induced magnetic field in the loop, well, if delta phi is into the page and decreasing, then the induced magnetic field is going to act to oppose that change. It's going to try to replace all the x's that are being lost. Okay, now we need to find the magnitude of the induced EMF. Okay, well, the magnitude of the induced EMF is all of this stuff divided by delta t, which is 0.15 seconds. And that works out to be 2,600 volts. And then the direction of the induced current, well, if the induced field is into the page, fine, okay, so now this current loop is having a field that's going into the page. The right-hand rule tells us that the current's got to be going around clockwise. All right. That's it, we're done.